Let's talk about different types of unsupervised learning techniques. In unsupervised learning, as we know, the learning algorithm is just shown the input data and asked to extract knowledge from this data. It is unsupervised because there is no known output, no teacher to instruct the learning algorithms. In other words, in unsupervised learning, the model is not provided with any labeled data or specific instructions about what patterns to look for. Instead, the algorithm tries to identify patterns and relationships in the data on its own. For the sake of simplicity, let's categorize these techniques into two types: unsupervised transformations and clustering. Unsupervised transformations of a dataset are algorithms that create a new representation of the data, which might be easier for humans or other machine learning algorithms to understand compared to the original representation of the data. For example, dimensionality reduction, which takes a high-dimensional representation of the data, consisting of many features, and finds a new way to represent this data that summarize the essential characteristics with fewer features. There are several types of unsupervised learning techniques that are related to unsupervised transformation of a dataset that exists, such as dimensionality reduction, anomaly detection, and association rule mining, etc. There are some unsupervised transformations that are about finding the parts or components that make up the data. Like anomaly detection, that involves identifying data points that are significantly different from the rest of the data. It is useful for detecting fraud or other unusual events. And we have association rule mining as well, which is used to identify relationships between different variables in a dataset. It is commonly used in market basket analysis to identify items that are frequently purchased together. Clustering algorithms, on the other hand, partition data into distinct groups of similar items. Clustering algorithms group together similar data points based on their characteristics. The goal is to identify groups of data points that are similar to each other and distinct from other groups. Similarly to classification algorithms, clustering algorithms assign a number to each data point, indicating which cluster a particular point belongs to. For example, uploading photos to a social media site. To allow you to organize your pictures, the site might want to group together pictures that show the same person. However, the site doesn't know which pictures show whom, and it doesn't know how many different people appear in your photo collection. A major challenge in unsupervised learning is evaluating whether the algorithm learns something useful. We will talk about such common challenges related to unsupervised learning in the next part.